Okay, Algebra 2 kids, this is section 2.5 that we're doing today. I'm going to start this by saying that, so today's Wednesday, and we don't have school Thursday, Friday. Section 2.5 is the middle of the chapter, and so on Monday, I told a couple of you guys this yesterday, Monday we will be having a mid-chapter quiz over chapter 2, or for the first half of chapter 2. And so make sure that you are ready to go for that quiz on Monday. You can use your notes on that quiz. So make sure that you have all of those kind of compiled into one area and have all your notes filled out and ready to go. So you can use your notes, but that will be ready for you on Monday. Okay, so be ready for that. All right. Monday, when we went through section 2.4, we talked about solving systems by graphing. So solving systems of equations by graphing. And we kind of said that, I'm just going to review up here, okay, that when you graph functions, you can have like one of three scenarios happen, okay? So you can have either when you graph them, they somehow, some way connect and they form just one solution. You can have the two lines not cross each other where they're parallel, and this has no solutions or no places where they cross. Or you could have two lines that are like the same line graphed on top of each other, in which case there's infinitely many solutions. Okay, they're touching each other at infinitely many places. Okay, we're going to see that today, but we're by not graphing, by using algebra just to solve them. Okay, there's two ways of solving these. One of them is substitution. So that's method number one. And then here in a little bit on the second page, right before example 4, we have the second method, which is elimination. Okay, so substitution, let's go through this. And the very, very first step when we do substitution is we want to solve at least one equation for one of the variables, okay? And then step 2 and 3 involve the actual substitution itself, okay? So here we have two functions that are linear functions. I know they're linear because it's just x to the first power, and then we have a y, and those other things we've talked about, how to identify linear functions. So I have this right here, and they want me to solve this by using substitution, okay? So I have options here, and what I can do is I can either solve the top equation for x, the top equation for y, the bottom equation for x, and the bottom equation for y. I want to do the easiest one possible, and so it should kind of like ring a bell to you that since this number doesn't have a coefficient in front of it, that might be the easiest one to solve for. So let's go ahead and do that one. Where's my eraser? There we go. So let's go ahead and we're going to solve for this guy. We're going to solve for this x, okay? And that's what they do right here. So we're going to follow their steps, and they say, let's solve for that x. So if I subtract 2y to the other side, I have x is equal to, I'm going to say negative 2y minus 12. Minus 12. Okay, so that's what my x is going to be equal to. Now what I do is I take this top equation, and the x that I saw right here, I'm going to plug that in for x in that spot. Okay, I've solved for x in the bottom equation. Now I'm going to plug it into the top. Okay, so what I've done here is 8x minus 3y. I'm going to take in this x, and I'm going to replace that x with negative 2y minus 12. I'm just plugging that in there. Okay, and then I just continue to solve. So I'm going to distribute the 8 through. So that becomes negative 16y minus 8 times 12 is 96 minus 3y equals negative. Okay, so I've just distributed the 8 through, and I'm just going to continue to solve. Negative 16y can be combined with negative 3y to make negative 19y minus 96. And then if I add the 96 to the other side, negative 1 plus 96 is going to be 95. And if I divide by negative 19, I am going to get something like maybe 5. Let me see if that's right. Yeah, 5. Negative 5. Negative 5 is what my y value would be. Okay? Divided by negative 19 will be negative 5. So I have found the y value. Okay. Now what I need to do is I need to go up into one of these two equations and different lines so that I can solve for x. This is technically the first equation. first equation. That was silly. I don't know why I did that. Doesn't matter, right? Like, it means nothing if we don't know what we're solving. So that is the place where the two linear functions are going to cross each other. Okay, -2, -2. Okay, let's do another one. Go to example 2, and this, they're giving us a little hint here, when there is not exactly one solution. So here we're going to end up with one of those two scenarios where we have either lines that are parallel or two lines that are living on top of each other, okay? So we'll see that here in this example, okay? All right. In this problem, we have like our variables are x and y and y and x, okay? And the really nice thing is that our y is already solved for in the second equation, okay? So all I have to do is take this stuff and substitute in for y there, all right? So that's what they've done here. I'm going to use their work, okay? So 2.5y, instead of this y, I'm going to put the 2x minus 11, and then I'm going to distribute the 2.5 through, okay? So negative 5x, he's just chilling. 2.5 times 2 is 5. 2.5 times 11 is, I got to think, 22 plus 5.5, so 27.5, I believe. Yeah, 27.5, okay? So here I have negative 5x plus 5x, and those two things are going to cancel with each other. So I've got negative 27.5 is equal to negative 15, and my variables are gone. I have no x to solve for anymore. So all I'm doing is I'm looking at this equation, what I have left, negative 27 equals negative 15, and I say that doesn't even make sense, right? When does negative 27.5 equal negative 15? Well, it doesn't. So I have something where I have no solution. This system has no solutions because negative 27 equals negative 15 is not true. That's not a true statement, okay? So in this case, I have this. Where did I go? Where did I go? I have this case happening where I have two lines that are parallel. They are not touching each other, okay? And that's how that works, all right? I'm going to go ahead and skip the story problem on example 3. Let's move right on into elimination, the elimination method. Out of the two methods, I like elimination better. I don't know which one you'll like the better, but this is the one that I've always kind of been drawn to. So in the elimination method, you're going to end up multiplying one or both of the equations by a number, okay? And then you add the equations together. You add the equations, and then you, in the last step, you'll end up substituting. So if you solve for x, you'll substitute that back in to solve for y. So those are kind of our 3 steps that we're looking at, all right? And you've probably had this in Algebra 1 before, so hopefully these steps are making sense to you. But what we're wanting to do is I want to be able to add these two equations together somehow so that I eliminate either the x or the y, like they cross out, okay? So here's what we have. If I try to add them right now the way that they are, negative 2 and negative 4 makes negative 6x. Well, those don't cancel. Negative 9 and negative 9 makes negative 18y. Well, those don't cancel, right? But they would cancel, the y values would cancel if one of them was positive. So what I'm going to do is I'm going to take this equation right here, this bottom one, and it doesn't really matter if you do the bottom one or the top one in this case. I'm going to multiply through by a negative 1. So I'm going to multiply everything through by a negative 1, okay, on the bottom. All right, so when that happens, I'm going to have this negative 4x is going to become positive 4x. Negative 9y is going to become plus 9y, and negative 23 becomes positive 23, okay? Then I'm going to take the top equation, which I left alone, I didn't do anything to, and I'm going to add that to the bottom one, okay? So here we go. That's what we have going on here. They flipped the signs of the bottom one, so 4x, 9y, 23, and I'm going to add those two together, okay? So negative 2x plus 4x is going to be positive 2x, okay? 2x. Negative 9y and positive 9y goes away, and then negative 25 and positive 23 makes negative 2. And then I'm going to divide by 2, and negative 2 divided by positive 2 is negative 1. So that's my x coordinate, okay? So right now at this point I have negative 1 comma something, and I need to figure out what that something is by solving for y, right? I have the x coordinate. So they went ahead and they used I'm not sure which equation they used. They used the second equation. It doesn't matter which one you use. We're going to plug negative 1 in for x and solve for y. It doesn't matter which one you use, so they're using the bottom one. Doesn't matter. We'll just use the same one they did. So they've plugged negative 1 in for x right here. They've done that. And now they're solving negative 4 times negative 1 is positive 4. Okay? And then what they've probably done is they've subtracted 4 to the other side. So I've got negative 27 is this guy. And then negative 9y is just chilling out. He's just hanging on for the ride. If I divide by negative 9, I get positive 3. So I have negative 1, positive 3. That's going to be my solution. And again, that's the place where these two linear functions are going to cross each other. If I were to originally graph these two guys, they would cross at negative 1, positive 3. Okay? And that's using the elimination method. All right? Let's do another one. And this is one where you have to multiply both of the equations by something. So I'll go through this maybe a little bit faster. Here I want to eliminate my x's or my y's, okay? And usually you can see that like one is maybe easier than the other. In this case, I'm going to have to do something to both equations. So I can either change both of these x's to be 6, because 2 and 3 both go into 6, or I can change my y's to be like 20, because 5 and 4 would make 20. Okay, and so it doesn't matter which one I do. Let's see which one they did so that we can they multiplied, let's see, they multiplied the top equation by, they changed them to 6's. Okay, so let's do that. Let me see, they left, oh, what a mess they did. Okay, so they multiplied this top equation through by 3, okay? And when I do that, this is going to become 6x. They multiplied the bottom equation by 2, which is going to make this 6x, okay? Now, the problem is I want one of them to be negative. So they went ahead and changed this bottom guy, I think, to be a negative 2. I'm just going to write my work out over here because I don't like the way they've written their work, okay? So let's multiply through by 3 on the top. 3 times 2x is 6x. 3 times 5y is 15y, and 3 times 1 is 3, okay? If I multiply through by a negative 2, I get negative 6x. Negative 2 times negative 4 is plus 8y, and I get equals, that's going to be positive 20, okay? And then I'm going to add. So these two, if I combine them, if I'm adding those two together, those cancel out. 15 and 8 is 23y. Equals, hey, 23. If I add those together, divide by 23, that's going to give me y equals 1, okay? Then I just have to plug back in. I'm not sure which one they plugged into. I'm just going to do my own thing. I'm going to plug into the top one because I don't want to deal with a negative 10. Let's just plug into the top. So I'm going to plug 1 in for y because that's what we solved for. 2x plus 5 times 1 equals 1, okay? All right, so now 5 times 1 is 5. I'm going to subtract the 5 to the other side. I have 2x equals 1 and negative 5 is negative 4. And if I divide by 2, I get negative 2, okay? And then I'm going to write my answer as an ordered pair. So x was negative 2, y was 1, so I have negative 2 comma 1. And again, that's the place where the two lines cross each other, okay? Those two linear functions. So that one did come out with a really nice answer, okay? But I had to multiply the top equation and the bottom equation by something in order for them to cancel, okay? All right, we'll do one more example, and this one's one where you're going to have something funny. So either I'm going to have two lines that are parallel, or one line or two lines that are living on top of each other, where I have either no solutions or infinitely many solutions. So let's see what we have going on here. Okay, let's do this. Let's look. I'm going to put my work off to the side over here. Okay, so I've got 18x and 6x, and I've got 21y and 7y. So I want to make those all the same number. So let's say I want to get rid of my x's, okay? So if this is 18, 6 does go into 18, but I would have to multiply him by 3. So I'm going to take that bottom equation, I'm going to multiply 3 by 3. But what I'm going to do is I'm going to multiply by negative 3 so that this becomes negative 18x, so that he will cancel, okay? So negative 3 times 6x is negative 18x. Negative 3 times 7y is negative 21y. And then negative 3 times 2 is negative 6, okay? All right, let me get rid of kind of my mess that I've got going in here, okay? And now what I'm going to do is I'm going to combine my stuff here, okay? Imagine that middle row is not there. 18x and negative 18x, that goes away and my x's are gone. 21y and negative 21y goes away and my y's are gone. So that's kind of puzzling. I end up with nothing on the left side, which means I have 0 over here on the left, okay? On the right, I have 14 and negative 6. And when I combine those, that makes 8, right? 14 and a negative 6 makes 8. So 0 equals 8. Okay, and when does 0 equal 8? Well, 0 doesn't ever equal 8. So here I have no solutions again. That doesn't make sense. That's not a true statement. I have no solutions. And so what happens is if I were to graph those two lines, I would end up with parallel lines. Okay, now we didn't do an example of where you end up with infinitely many solutions, but what does that look like? Okay, so that would be the case where, let's say we had everything cancel out on the left side, so we had 0, and let's say everything also canceled out on the right side and it was 0. So let's say like down here I got negative 14 instead of negative 6. 14 and negative 14 are going to cancel as well. So in that case I would get 0 equals 0 like I have here. And we say, okay, when does 0 equal 0? Well, 0 always equals 0. So we would end up with infinitely many solutions, okay? You might also get something like x is equal to x, or maybe 7 is equal to 7. Something where you end up with the same thing on both sides of your equal sign. And when that happens, of course, x is always equal to x. 7 is always equal to 7. So you would end up with infinitely many solutions. That's what happens when you have infinitely many solutions, or we have the same equation on top of each other, okay? So that's kind of how that works, all right? So hopefully that was not so bad. You should have had that maybe in Algebra 1, so hopefully that's kind of bringing back, refreshing your brain a little bit. Here's the homework problems for tomorrow. Not tomorrow, Monday. These first 3 are going to be substitution. The second 3 are going to be elimination, and then 22 is just kind of a little bit of a story problem. So there's that. Write those down. Use the time in class to get started on those. Help each other if somebody's struggling. You guys can check your solutions or your answers. I don't care. That's fine. But use the rest of the time to work and make sure you're ready for your quiz on Monday. Okay?